without further ado, let's introduce Nguyen, who is the first speaker for today.
Hi everyone, so I will be the first presenter today. So today I will talk about the typing infrastructure in Ruby 3.0. And before I start, I would like to emphasize that this talk is not about the underlying typing in Ruby, but it is more about the overview and the context of the recent new typing features in Ruby. And people are talking about that recently. And when I talk to people, many of them are still really not sure about when or how they can apply the times Ruby. So this talk will also provide some examples for you to get started with the typing Ruby. So let's get started. And yep, as a the agenda of today's talk is just about three sessions. The first one is that I will talk about the history of the Ruby type system. Next, I will talk about the shiny Ruby type annotation shipped in Ruby 3.0. And finally, I will talk about the survey step and other community approach to provide typing in Ruby. And it's really simple. And before I start, and yes, about me. So recently, I'm a software engineer at GitLab, and I'm working remotely in Vietnam right now in the Go Inspire we work. And I am a Ruby lover, and I really hate Rails since 1914. And I'm a long-time member of the Ruby community. And if you don't know, Ruby community is a local dev community in Vietnam to discuss everything on just a chat room, so that you can join later if you want. And I'm recently the author of Ruby Jar, which is the Ruby debugger. I'm going to provide better experience when you work with Ruby. And finally, I'm the core contributor of Ruby Kafka. If you like it, you can contribute some issue and I can fix that. And this is just something about me. And just disclaimer, all the content in the talk is about me from my own perspective. It's not from my employer or GitLab. So it's just a disclaimer to disclose some thing later, legal thing later. Okay, so let's get started with a really bad example. When I provide some examples for a talk, it's really hard to demonstrate everything in the talk. So I will get started with a first snippet to manage the order for an e-commerce website. We have two classes. The first class is about the product, and the second class is the order. The product is to create a product in the e-commerce system. Is just have a name and a price, and the order is to manage the list of products and the quantity one users put into the cart. And the order just has some methods. The total price is to calculate the current price. It is just equal to the product price and multiplied by the quantity and sum on them. And the average price to have the e-commerce website owners to get a really overview of the website. So let's have a quick look at the example. It's really simple. So what will I do with this example? Right now, when someone, the owner of the e-commerce website will raise some product, name the table, chair, and a laptop with the price next to it. And when the user goes to the website, they raise an order object and add the product into that. And finally, and can put a total price and average right here, and it will produce this result. And that's it. It's really easy to use those classes. And if you can spot there's a small error, but we will cover that later. So in Ruby, it's really easy to implement something, and you can literally implement some working rule to type in the weekend to create a whole e-commerce website in the weekend. Because Ruby is really a flexible language. It is really fast to develop, and to do that, Ruby is the dynamic type language. What does it mean? It means that there is no type checks at the compile time. You can put anything into Ruby. You can throw any variables anytime in Ruby, and it still just works. It works means that it can run, but it doesn't mean that it will produce the right results. But at the first stage of product, it's not very important to produce or to check on the errors. So on the type talking is done at runtime. It means that when you run the Ruby shortcode, it will take the variables, take the input, and it will evaluate the shortcode, and it will throw some errors at you when something wrong happens. And it is happening at the runtime. It means that after you deploy your application into the production environment. And thanks to that, the development and the typing time is really fast. However, it is really easy to mess up with the time. Like right here, if you allow the user to input something into the system and you forgot to type check or forgot to validate the result, the system can mess up really badly. Like right here, if you allow the user to input the price of the product by a string and you forgot to cast the string, everything will well go up. Or when you put something right here and it method doesn't contain some method that you want, it's still well fuck up and it's really hard to detect. And in my daily development activities, what I look at is something like this on the version. It's all over the place, and the most common error is the undefined method, blah 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 for new class, because we just well allow everything to flow into our Ruby system. So all of those errors can be prevented in the compile time. It means that if we can prevent all of those before we deploy something into production and before even the Ruby source code gets executed. So the Ruby also has some scaling issues with the typing. And as soon as the scaling, the support becomes more complicated, it's really hard to get into a class or get into a file and swap to know whether what the variable is. It can be a string, it can be an integer, or it can be even another method code. It's particular in Ruby. Ruby is infamous of the magic. It means that when you call something, it's really hard to tell whether what it is exactly means. So the more engineers you on, the more support becomes complicated. It's really hard to scale with it. That's why people come up with some idea how to about adding the typing system into Ruby. It means that we have to specify whether a variable or the method call input types. So after you add the typing system, you can validate on the Ruby code at the runtime, at the compile time before it gets deployed to the production. And Ruby further must already talked about that about 7 years ago in a Ruby conference. So, yep, in 1914, he talked about Ruby 3.0, which has been already released just for 3 months. And in this talk, he managed to bring up the new vision for the next 10 years. And the three visions are about the concurrency, just-in-time compiling, and static typing. There are three big items. On the top are only deployed and released in the Ruby 3.0. And today we cover the static typing. And in the talk, he particularly mentioned that Ruby should keep being Ruby forever. What does it mean? It means that when looking with the typing system in Ruby, people have to be aware that there are some requirements. The first one is that we must keep what makes Ruby on a great language. Ruby is a beautiful language. It is not fast, but it is easy to develop, so that we do not convert Ruby to a fully static type language by default. It should be dynamic type always. Second, Max really loves dog typing. I don't know why. So he decided to keep the dog typing. I don't know why too, but well. And the next one is that we don't change the language grammar. If you look at other programming language, you can see that the type declaration is really hard to get it right. In some languages like the Rust, if we decide some static type, it really went ugly. So Max don't want to mess up. Ruby is only an 11 language, so let's keep it there. And we will try to find a way to do that. And finally, no, not before the last, we must honor the community. The community is the core of Ruby. The community here is about the Ruby gems. It's about the Ruby, the adoption of the community, and all the effort that the whole community was putting in to develop Ruby. Unlike Python 2 and Python 3, which the author messed up the whole community and create a big backward in compatibility. In Ruby, they don't want to do that. They want to adapt the typing system really, really slowly. They don't want to mess up anything. Those are the requirements for the typing system. So now what? Okay. In the Ruby 3.0 release, Ruby is decided to follow the radio typing. This is the first item. And it's lucky for us, there are no syntax related to type are introduced. Everything is kept the same. Everything runs is the same. And Ruby introduced the two new components for the typing infrastructure, RBS and typer. I will talk about that in the next slide. So, what is radio typing? It means that at the same time, we allow some variables and some expressions or entity classes have a type. And we also allow on other things are untyped. It means that we have type system and untyped system existing coexisting at the same time. And when we get started, everything will be untyped. And gradually, we will try to add the typing into the classes we newly created, into the library we add the system, and we gradually do that until everything is typed. These are very simple and very similar because it is only applied in TypeScript and Python. If you use TypeScript, at the time Microsoft introduced TypeScript at the first time, everything was untyped, just a little library applied the type only. And right now, every major library release the TypeScript version. It's really a huge successful process. And Ruby is following the same path. We just added really early step. And Python, well, is another story, but just for the typing system, Python is applying the radio typing as well. And Ruby is doing that. So to do so, Ruby introduced RBS. So what is RBS? RBS is the language to describe the structure of a Ruby program. And RBS contains a lot of type signatures and are stored in a dedicated RBS file. And you have to create the file manually. So let's look at the example we have. We have a product.rb, and this product case is really simple class. And then we have to create a RBS file next to the RB file. And in this file, it doesn't contain anything except the type signature. What is the type signature? A type signature is just some annotation. It makes what is the type of a particular component in the Ruby file. For example, in the product class, it will annotate that the ancestor name here is a string, and the price here is integer, and the initializer here will get the name as string and price as integer. That's it. It just annotate the style. What it annotates, it doesn't do anything else. It just tell us what is the type of the component. And for a more complicated example, in each example we have two instance variable, and here we have to declare that the cart instance variable here is a hash of which has a clear product, and the value is the integer. And right here the total quantity is the integer. And for each method we have declared what is the return type, what is the input parameter type, and so on. So when introduce the RBS product, Ruby really supports only all the complicated Ruby feature. And for example, in this is a really complicated example. But now we add the final price into the class order. And the final line here we receive a block of lambda that receive an order that return an integer here. Okay, so it is an example of the order. And Ruby already support this. So the final price method here receive a block that receive an order, receive an integer, and then the whole method final price return the integer. Ruby support this, and it nearly support all the complicated Ruby features. However, if you look carefully, it's really hard to tell and really hard to write the type signatures for this pop method. It's too manually, and if we change something, it's just too hard to change in future. So when we apply the RBS, we can use one CLI command to list out all the method or list out a particular method of a class here in a CLI. And that's it. RBS is does. It doesn't require any other feature. So because RBS is just about the definition language, it don't have any fancy features we are seeing in some other programming language, like the static analytics, like auto completion, language server protocols, etc. It's just a language to describe the file structure. That's it. And it was born to become a standard. It's not used in workflow. I mean, in the upper layer that you are using every day. And in the future, Ruby standard list will ship the RBS file by default. And by default, it means that the Ruby plugin will work on the RBS file, not you. And finally, the gem console ship the RBS file. So, Ruby 3.0 provides something we cannot use. Now what? Luckily for us, oh wait, I forgot to talk about it. Okay, let's go back. And because the RBS files are really hard to implement and hard to write manually, the Ruby team creates an utility called typer, and this one will generate the RBS file for you automatically. But how? It uses something like the struct interceptor, but I will not go into the detail. But you can just know that when you run this command, it will generate the RBS file for you. Of course, the RBS file are auto-generated. It will be wrong in many cases. You have to edit the file to get it correct. You have to write text for the RBS file to get it correct. But it is the starting point for everyone who wants to contribute into the process. So, like I said, Ruby don't ship with any typing infrastructure you can use directly. But the Sorbet can. The Sorbet is the mature type checker for Ruby. It's actually it was born before Ruby RBS, and we can claim that RBS was born to support Sorbet. What does it mean? It means that even before the Ruby RBS or Ruby plugin has any idea about the static type, the Sorbet already exists, and it's only used in Sprite with the millions of Ruby supports and thousands of engineers. It is quite mature now. So, Sorbet is following the radial typing at this point by default. And Sorbet provides a lot of many other features. One of the notable ones is that Sorbet provides a valid Ruby DSL for type signature. What does it mean? It means that you can put the type signature inline inside your Ruby file directly. You don't need to have a dedicated file just for the typing. And all of the DSL that the Sorbet is providing are the valid Ruby system. There's just some DSL of the team. I will go into the example later. And Sorbet have a lot of other uh, features, such as the static analytics for you to catch on the error at the compile time. And it supports the auto completion in your editor or in your IDE. And it even supports the type signature file, just like Ruby, before RTL. So let's look into some example. Okay, Ruby support inline type signature. Okay, in the right the version we have to write when we use the RBS directly. We have to have the Ruby file, we have an RBS file, also combined to create something meaningful. But for short, we can just declare the type for a method for on the attribute accessor directly on top, on the above the method. For example, right now the accessor name here is string. It's equivalent to this one. And right now it is this method initializer receives the name, the string, the rise integer, and return nothing. It's a little bit different because it's auto-generated, but exactly the same. The difference is that, and you can see because we extend the Sorbet extensions here, they are the valid syntax of Ruby. We can use the Sorbet in former versions of Ruby before 3.0. We don't have to wait for 3.0 to use the typing system. That's the first benefit. The second benefit is that the types are keeping in the same with the support. It's really hard to get the type signatures outdated. If we keep something like this, we have to keep and have to wait and have to make sure that the type signature file are in sync with the keyboard. Most time we forgot or we messed up something. In the more complicated example, it's become well, a lot, but let's look at it closely. Right now, it's the instruction, I skip that. However, in the this product, the params here is the product type, the quantity in the integer, and return a product. And right here, it just return integer. And right here, it can return float or nil. Yeah, show by support on this in the same file. I personally prefer this style over this style because well, that is easier to manage. Yes. And when it does that, it supports the static analysis. So what does it mean? It means that if you do something wrong, you can run a command survey type check and it will catch all the type errors for you. Right here, because the add product, right here I support the product and the quantity is an integer. If I pass something here like float or string, you can see that it can point out which having some issues, typing issues going on at the right time before you deploy anything. Yes. And if you apply the horn show by typing system in the horn support, it's just the same as you use the starting time. On the event stride doesn't get into that level yet. The team is working on to make it a really start time. So beside the this one. So in on example before I'm talk about the on example that receive on a block a blender is the input, and right now if we just slightly change something, for example in this we just allow that the blender can return nil, so I can even capture that. It is really complicated and sophisticated to capture everything it can, and right now you can just be confident about the type right here. So next, Showbase can support the output condition via the language server. It means that if you use some major editors like Vim, Emacs, or anything, Visual Studio Code, you can be beneficial by this. It can integrate directly into your editor, and you can just have the auto condition and even the static analytics right into the editor on everything experience. And finally, Showbase supported signature type. One of the biggest benefits of the dedicated type signature file is that you can write your own signature file for a gem, or you can get the type signature from the community or from the gem directly. And in Showbase have a direct repository that contains all the type signature the community are maintaining. It means that you don't have to care about the type of gem. Showbase will take care of it. And as long as files are setting, so you can be confident about that. And right now, Showbase is using its custom signature syntax called RBI. But in the future, when the team is working on that, and then when they finish, it will use the RBS file directly. It is the purpose of assistance of the whole RBS system, so that the whole community, Showbase, and all the type checkers in Ruby can use the same standard. And if the team finally done the migration, the Ruby community ecosystem is unified. It means that you can use Showbase or you can use other type checkers in future without changing anything. Maybe we work interchangeable. Yeah, that is biggest benefit of the RDS. And okay, now what? After the host presentation, you can be curious about what you can take away after the talk. First, type system is at rather early stage. It's just like type read at the first stage. So it will take some time to be mature, and you can contribute into that process. And second, you can forget on about RBS and type work. Just forget everything I said. You just need to know that they are not important to you. And you can even ignore the whole typing system in Ruby. They are optional. You can opt in anytime. But if you don't, it's okay. Ruby is still a dynamic language. You can just use like before. And if you really want to up it, let's use survey. That is for the presentation. And if you want to go in really deep into this topic, I gave some reference about the standard lib, about the comparison, the RBSA, RBI, or even a detailed presentation of the practical uses of the survey in your cert. And you can read the reference anytime. And that's it for today. Thanks for listening. Do you have any questions?
Yeah. Have you used survey in your college?
I use survey in some of my side projects, not in the company project. Yeah.
What's your experience?
Well, my experience is that I really like the idea. I really like how it started the issue. But because my side project was GM, so in runtime, it's really hard to like include the GM into other projects. Because if I declare show by the dependency of my GM, other people have to use, have to include the show by in their recipe. Many people don't. So I will have to try something to work around. Yeah, but overall, it's been a really great experience. Yes.
Do you have an idea why they choose to have separated files like areas? Just like to be nameless for those who don't want, or is there some other benefits from using different files?
It's a really debatable topic. It means that uh, when they use the separate file, they don't need to care about the current running system. It means that everything runs exactly the same. And they just can gradually add the file into the add the tiles via the files separately. It means that well, in many companies really big things are working together so they can be beneficial of the finance system. And then once more they're working on timing, they don't have to mess up other people. They just need to focus on the timing part and the infrastructure. So that's the biggest benefit of the electric car. Other question? Question now, right?
What?
Is there any questions or no? On the
No.
last week? No. Okay. So thanks for listening today, and let's move on to the next presentation.
Okay. Thank you, Min, for your presentation.
Thank you.